In 2008, Ryan Kennelly set the world record for an assisted bench press. Wearing a bench press shirt, he lifted a staggering 487.6 kilograms. If he holds his weight stationary at 60 centimeters above his chest, is he doing any work? Since the weights are stationary above Ryan's chest, then the net work done on the weights is zero as there is no acceleration. Remember that work is defined as a product of force in the direction of the displacement multiplied by the displacement, and force is equal to mass times acceleration. So if there is no net acceleration, then there is no net force and there is no net work. We saw in the video on work done by friction that there can be multiple forces doing work on an object in opposite directions. The same is happening here, where there are two forces acting against each other. We have Ryan working to lift the weight up 60 centimeters above his chest by applying an upward force. At the same time, we have the force of gravity trying to pull the weights back down to Ryan's chest. These two forces oppose each other. So the work done by the applied force in the upward direction is F times h, where h is the height that the weights have been displaced. And the work done by the gravitational force in the opposite direction is mgh, where mg is the force due to gravity. The term mgh is called the gravitational potential energy, which we'll cover in a separate video later. So we have one upward force and one downward force. Here we are defining going up as positive in the equation. At its maximum height, where the weights are stationary, the work done by Ryan is balanced with the work done by gravity, and there is no net work done on the weights. As Ryan brings the weights down to his chest, he is reducing his upward force, and therefore the work, which will consequently be less than the work done by gravity. The weights will move in the direction of the net force, which will be down. Conversely, in order for Ryan to lift the weights up again, for his next rep, he has to increase the upward force so that it is greater than the force of gravity, resulting in a net upward force which does work to raise the weights. So whenever an object is raised vertically, work is being done against gravity to lift the object up. When the object is lowered or falls down, then gravity is doing most of the work. So how much work does Ryan have to do to balance the work done by gravity and hold the weights at 60 centimeters above his chest when the mass of the weights is 487.6 kilograms? Now compare that to how much energy is found in a standard size Mars bar and consider how many reps Ryan has to do to use up the equivalent amount of energy in that Mars bar.